Hello everyone, myself Padala Rajashekar, Assistant Professor, Department of Civil Engineering, SR University, Warangal. This is my second lecture regarding hydrology. So, previous lecture I have covered what is hydrology, hydrological cycle, and what are the factors affecting watershed and what is watershed, and these all things I have discussed. If anyone is missing, please refer to that video. And coming back to today's topic, like second lecture is related to precipitation. Previously in an hydrological cycle, I told the main source of water is like rainfall, that is precipitation. Then what is precipitation? What are the forms? And what are how they like types, forms, and is there anything more discuss? We can do it later. So coming to the introduction. Now the first thing introduction, precipitation. Precipitation means you can it's nothing but rainfall. So is a form of solid or liquid. As I mentioned in the previous lecture that it may be three types: solid, liquid, gaseous. So precipitation particularly with respect to solid or liquid water that falls from the atmosphere to the earth's surface. That may be in terms of rain or drizzle or hail, snow, or examples of the precipitation. That means it comes under the forms. So types also will be there, we will discuss later. And after precipitation there will be the kind we will discuss in upcoming slides, is called evaporation and transpiration. Evaporation is nothing but the thing which evaporates water from water bodies like ponds, lakes, rivers. The thing which evaporates from plants is called transpiration. So evapotranspiration is nothing but evapotranspiration is the process which returns water to atmosphere and thus completes the hydrological cycle. Evapotranspiration consists of two parts: evaporation and transpiration. So previously I have mentioned, and again I am mentioning, evaporation is nothing but the water which is evaporated from the water bodies like ponds, lakes, rivers. And transpiration is nothing but the water which is evaporated with respect to plants. So both combinedly we call it as evapotranspiration. So next one we'll see precipitation types. So the basic thing we have to understand before going into the precipitation forms or anything, and to understand the measuring devices, rain gauge density, and these all things further we can go. We have to start with respect to precipitation types. So there are three kinds of types. One is frontal precipitation, convective precipitation, orographic precipitation. So these three are the very important kinds of types. The frontal precipitation is a precipitation that is caused by the expansion of air on ascent along or near a frontal surface. So convective precipitation is caused by upward movement of air which is warmer than its surrounding. So this is very important, warmer than its surrounding. This precipitation is generally slower nature with rapid changes in the intensity. And finally coming to the orographic precipitation is nothing but is caused by air masses which strikes the mountain barrier. So for example, this is like air masses which strikes the mountain barrier and causes condensation and precipitation. The greatest amount of the precipitation with the fall on windward side of the barrier and little from the leeward side. This is windward side, this is leeward side. For mountain, this side is windward side and this is leeward side. Now we understand there are three kinds of the precipitation types. One is frontal, one is convective, and one is orographic precipitation. Now going with the forms of precipitation. So I told precipitation is nothing but the rainfall, but we have to understand when we want to go for analyzing certain watershed. So we have to know before itself what kind of the area is receiving. For example, if want to do research on particular Himalayan region, for example, so there will be snow kind of thing. And if you want to do other places which there is no snow, that is called rain. And rain is also is categorized into precipitation is categorized into different forms. Like I will show the glimpse: rain, snow. as I mentioned. So these all the forms of the precipitation. So now we will tell first one comes under rain. Rain is a form of precipitation which is in the form of water droplets. So obviously everyone knows that rain of a size larger than 0.5 mm. This is very important. And the maximum raindrop size is about to 6 mm. Drops of larger than break up into smaller drops as falls down the earth's surface. So now why we have to understand these things means we have to do classification based on that we can give the forms of the precipitation. But this is very predominant, like this can be like rainfall is predominant form of precipitation, and therefore the term precipitation is used synonymously with the rainfall. That's what. So rainfall we are listening everywhere. The magnitude of the rainfall shows higher temporal and spatial variation. This variation causes the occurrence of hydrological, the majority of the areas are covered with respect to only less areas are covered with respect to snow. The rest amount of the covered with respect to without the snow. That means rainfall. The analysis in the hydrology mostly with respect to rainfall. So this understanding this size, form, and that a droplet, everything is very important before going into the any kind of analysis like floods and drought. Now coming to the snow. Snow means, as I mentioned, Himalayan region, you can take the snow consists of ice crystals in a flaky form. This is also very important, flaky form, having an average density of 0.1 gram per cc. Like it is also an important form of precipitation that usually forms in colder climates. As I mentioned, colder climates means you can take example of the Himalayan regions and higher altitude. Obviously, Himalayans are in the higher altitudes. Now, another kind of precipitation is drizzle. We come to know this thing. There is a slight drizzle. We can go like that. The kind of words we are generally we are listening day to day life. That means rainfall. We cannot like rainfall and drizzle are different. They are having like kind of with respect to the variation with respect to that it is having droplet size is less than 5 mm. Previously I have mentioned larger than 5 mm is rainfall. So if a droplet size is larger than 5 mm, they will call it as rainfall, and if it is less than, we call it as drizzle, and intensity greater than 1 mm per hour. Now another kind of things, glaze or freezing rain. So glaze is formed when rain or drizzle comes into direct contact with the cold ground at around 0 degrees Celsius. So this is 0 degrees Celsius. This water drops freeze to form an ice containing as a glaze. So next kind of thing is sleet and hail. Hail is having a like a greater than 8 mm. So we can consider it as hail. That means it will be very big. And sleet is frozen air drops that are formed when rain passes through the air in the atmosphere at the sub-freezing temperatures. So now we understood the types of forms of precipitation, and here we can go with the types and forms. You can see the hail, I told you greater than 8 mm. Now you can see in a reality this will be the hailstorms. We can tell the kind of words we can see listen in day-to-day life. So snow means we can make this image, and the sleet means like that, and rainfall means like that. So to understand basic things I have taken from this source, and I am trying to show visually like this. I hope you people are understanding. So now characteristics of precipitation in India. So in particular country like India, what are the characteristics? So features in rainfall in India. Rainfall in India mainly occurs in the months of, like most of the rainfall we can see through southwest monsoons. So for India, southwest monsoons, it will be obviously it will be around 80% of the contribution of India's overall rainfall. So majorly we can see in the months of July, August, and September average. So the Indian rains are chiefly orographic in nature. As a result, the region suited on the windward side receive greater rainfall than the regions located on the leeward side. As I mentioned, so now southwest monsoons will start actually from the state of Kerala, that means Western Ghats, like that. It will travel to Kerala and it will go to the entire India. That means windward side, as I mentioned orographic before in the terms of things. If it is a mountain, this is windward side, this is leeward side. So this will receive more, this will receive very very less. Next, another set of rainfall India is receiving is northwest monsoons that will come in December, like November, December, January, that seasons. Only a scant amount of rainfall is received from cyclones and convective rainfall. So major one is orographic rainfall in Indian conditions. Monsoon in India is irregular, not well distributed and unpredictable. By means there will be more flood, or else there will be like there will be flood at some areas, there will be drought at some areas. So this kind of things is very difficult to analyze and understand the conditions of the any kind of watershed. So now I hope you people are understanding characteristics of precipitation in India. Now as I mentioned previously, the sizes of the droplet, water droplet, if it is less than 5 mm, it is drizzle. Greater than 5 mm, it is 5 to 6 point, sorry, less than 0.5, and like greater than 0.5, it is rainfall, and greater than 8 mm, it is hail. Like that, I have given some classifications with respect to size. Then what about the centimeters? Like we can see 50 centimeters rainfall to 100 centimeters rainfall. So for that particular purpose, in particularly in Indian conditions, we are taking regions receiving like a hefty rainfall, like more than 200 centimeters is a heavy rainfall, moderate is 100 to 200, low is 50 to 100 centimeters, and scanty means very less, that is 50 centimeters to less than that, the classifications. So now the next thing is the measurements of precipitation. So once one can measure the rainfall at a place by placing a measuring cylinder graduated in a length scale, commonly in mm. So generally we are using with respect to the mm. This is very important thing which we have to remember. And in this way we are not measuring the volume of water that is stored in the cylinder, but the depth of the rainfall. This is also very important. So there will be two kinds of rainfall measurements. One is recording gauge and non-recording gauge. In practice, rain is mostly measured with the standard non-recording gauge, the details of which are given in Bureau of Indian Standards Code IS 4989-2002. The rainfall variation at a point with time is measured at a point. Either we can understand clearly the rainfall variation at a point is measured with recording rain gauges. Detail is given in 83 IS 8389 2003. Modern technologies help to develop radars which measures rainfall over an entire region. So now nowadays advanced technology also using with respect to measuring the rainfall with respect to radars. Now what is variation? Variation of rainfall. What is the variation of the rainfall? So rainfall measurement is commonly used to estimate the amount of water falling over the land surface, part of which infiltrates into the soil and part of which flows down to the streams or rivers. For a scientific study of hydrological cycle, a correlation is sought between the amount of water falling within a catchment and the portion of which water that adds to the ground. That's what I discussed earlier video also. For example, this is a river, this is a river, for example, this is a river. So in this particular watershed, what is the amount of rainfall? That is very important. And after losses, what is the, this is the outlet. Outlet means it is going to the end. What is the runoff? We can see the second point here clearly. For a scientific study of hydrological cycle, hydrological cycle means it's an process, rainfall, runoff, evaporation, condensation, again rainfall. It's a repetitive thing. That is the thing. A correlation is sought between the amount of rainfall falling within a catchment watershed or catchment or basin, everything is same, and the portion of which that adds the groundwater, and the part of that, that means whatever the rainfall is happening, the part is taken by, it went through like with respect to runoff, and rest of the thing is stored in the form of groundwater. So this, everything is related. What is the present situation of any watershed or river, we can estimate with respect to the only with rainfall. So rainfall is very crucial parameter. So if for an instant, nowadays the climate is changing, the climate change is happening everywhere. So if climate change happens like that, if climate change is happening continuously, the pattern, for an instant, as I mentioned, July, August, September is having rainfall, but we can see the rainfall in March also, in terms of February also. This is because of the climate change. So we should be aware of these things also. So how the climate change is impacting in this particular watershed with respect to whether the water is is able to store or is not able to store. So everything analysis with the variations of the rainfall is very important in the future trend, that we call as trend analysis. For next 100 years we can predict, and we can see what is happening, for example, what is happening with respect to time next 100 years for that particular area. So that is related to the research area field. Some of water that has fallen would evaporate at to extracted from the ground by plants. As I discussed, losses. This comes under, third point comes under losses. So infiltration into the soil is comes under also into the losses. So only the three things: some rainfall is happened, some loss is happened. After that, you will get runoff. This is what we will see. So some rainfall, after that losses, then we will get, sorry, this is equal to, there is a precipitation, that means rainfall, then there will be a loss, then it is called as a runoff. So now, as I mentioned, there will be a rainfall and there will be a rainfall and there will be a runoff. This is the outlet means last one, there will be a runoff. So there will be a runoff. So now, if you want to calculate for particular watershed or a river this thing, so this can be represented in terms of actually P, standard things. Okay, if we want to do, so we have to go that everywhere we can't measure every 100 meters or 200 meters, we can't measure rainfall, like rain gauges we can't install. There will be depending on some, depending on terrain, depending on the situation, depending on the things, we will arrange the rain gauges at particular locations. So if a watershed is having 4 rain gauges, for an instant, this A, B, C, D, this is the locations. With these 4 locations, we have to make sure that a single, for example, there is a rainfall happened and these 4 areas has taken reading. So how we have to represent for entire basin? So that is an important thing. If there is one basin, if you have one gauge, okay, there won't be any kind of this thing. But there is a one basin, we are having 4 rain gauges, means again we have to think what we can do, how we have to take a single value for that entire basin, like entire watershed. So now times in hours you can see here, first, second, third, fourth hours, first hour, second hour, third hour, fourth hour at A means this location they given, and the total is this. So for example, in a figure we are showing a catchment of a river is shown with 4 rain gauges for which an assumed recorded value of rainfall depth have been shown in the table. So it is the basis of discrete measurements of the rainfall, that an estimation of average amount of rainfall that has probably fallen over a catchment. So to do this kind of analysis, when there is more rain gauges, then there are three kinds of methods are there. One is arithmetic mean method, Thyssen polygon, isohydral methods. So these three methods are existed right now, like arithmetic mean method, Thyssen polygon, and isohydral. So in that best method is that usually this is like averaging only. These two are mostly used methods, and that particularly this will be a little precise. Isohydral method. Isohydral method. So now a rain gauge network. So I told that previously there is a watershed, there is a river network, but this river is divided into like here A, B, C, D, E, F. That means there are six gauges. For example, there are six gauges in a particular watershed. How it is decided? Six. Either it may be eight, either it may be 10, either it may be two. How? How it is decided? For this particular basin, this many rain gauges are required. So that we will see in the next upcoming slides. So as I mentioned regarding rain gauges, non-recording rain gauges. So first I want to discuss about non-recording type rain gauges. This is very important. This is standard one. Dimensions I will discuss first. There will be the funnel. This is called funnel, and a metal container. After that, collecting bottle, and this will be the ground level. And a concrete block is 600 into 600. Non-recording this one. Height is total height from the ground level is 305, and from here to this level is 203, and here it is 127. So this is a setup for non-recording gauges. So now the top, as I mentioned, 127 mm. Here you can see this is a standard one for non-recording rain gauges. The funnel discharges the water into the vessel. As I told, there will be a funnel, and you can see here the rainfall will come and it will go here to here to here. So now here the important thing is that we have to understand that at what time they will collect the reading. It's very important. So the rainfall is measured every day at morning 8:30 a.m. in Indian Standard Times. So this will give only the depth of the rainfall for previous 24 hours. That means every day morning 8:30 they will measure the what is the rainfall depth in that particular rain gauge. They can tell. So during heavy rains, measurement is done 3 to 4 days. So you people can ask, whatever the heavy rain days, is it sufficient only 1 day time? So there might be taken 3 to 4 times or more also, depending on the situation, depending on the rainfall. But non-recording type rain gauges are very important. That we call it as Simmons rain gauge. Usually we represent non-recording rain gauge, name it as Simmons. Now coming to, okay, now we discussed non-recording rain gauges. Now recording rain gauges. What are the recording rain gauges? Non-recording rain gauges, we understood the point is that per day only one time, that is 8:30 a.m. as per the Indian Standard Times. Then whatever the recording type rain gauges, then why they were differentiated? That means these rain gauges which can give permanent automatic rainfall recording without any bottle recording. That means this is a very important thing what we can understand. It will give automatic recording. That on recording rain gauge we have to go and we have to collect manually, but this is automatic. This can be done with respect to per hour or 6 hours or 12 hours. What are the things we can do? So advantages when compared with non-recording is that necessity of attendant does not rise. So intensity of rainfall at any time, like total, we can get, and data from inaccessible places like hilly regions also. For example, there is an hilly region, there we can monitor this kind of things where it is not accessible to go and to come daily, like manually we can't. There it will be very helpful. So advantages of recording rain gauges are it will be there. Advantages: human errors can be eliminated. One of the best thing, uh, when we are taking the reading, something we might do some kind of errors. That will be the things. Capacity of the gauge is large and time interval are also recorded. Disadvantage is the installation cost is very high because automatic we have to monitor, we have to see, and we have to look at the things, and recording is not feasible when faults in gauge rises till faults are corrected. That's what I told. If any repair comes, it is very difficult to we have to do, then only it will work. Until that the data is missing. So types of recording or automatic rain gauges. As I mentioned, there is a Siemens. Here it will be the total 5. There will be more also: tipping bucket, gauge weighing, gauge float or siphon. That is Siemens. It is siphons, rain gauge, optical rain gauge, acoustic rain gauges. Now factors governing the selection of the rain gauge. So there will be many factors, like you can consider the main important one: the distance of any object or from the rain gauge should not be less than twice the height. Whatever the thing, that twice the height, or we can take it, or in no case less than 30 meters. This is one of the important thing we can see. So now finally my question, like whatever I put that in a particular watershed, uh, how many gauges we can fix, rain gauges. Here in this particular criteria I am telling, I am showing a figure. Total 9 we can put. So here 9 means how? That means here you can see that if area is plain, one station is sufficient. That is 520 kilometer square area, one station is sufficient. One rain gauge is sufficient. Areas with 100-meter average elevation, if elevation increases, then what is the situation? Then every 260 to 350 kilometer square, one station we have to install. Then predominantly hilly areas, completely hilly areas, then with heavy rainfall, then 130 kilometers square we have to put. That means you see, from 530 to for 520 kilometers square we are going with one rain gauge, but for 130 kilometers square we are going with one. So as I mentioned, if this basin comes under hilly terrain, this may be 9, maybe the hilly terrain you can take, and this may be the plain terrain you can take. Like for an example I'm telling, it's not accurate. So if it is plain area, 520 kilometers square, one is sufficient. If it is a hilly area, 130 kilometers, we have to install one. So these are the some of the things, I like rain gauge stations for finding n is equal to cv by error whole square. This is a standard formulas, please go through these things. And one common type, that if there are 7 stations, then the what is the things we have to find. So optimal number of stations for the catchment. How many optimal number of the things? A catchment has 6 rain gauge stations in a year. The annual average recorded by gauges are as follows. So how many are the required? So estimation of the missing data. Missing data formula is this thing. As I told, there will be formulas will be there, and this is a missing data formula, and this is one kind of the problem. You people can understand easily what is this. So now the thing, losses from precipitation. So what are the losses from precipitation? So there will be rainfall and runoff. As I mentioned earlier, rainfall runoff is nothing but rainfall minus losses. So what are these losses? Always I am talking about losses. What are these losses? Losses means one is evaporation, evapotranspiration, infiltration, interception, watershed leakage. These are the kinds of the losses which we are going to discuss in the further slides. So what is evaporation? Evaporation means, in a simple words, if I want to tell in a simple words, uh, there will be a loss of water through like through evaporation from water bodies or ponds, lakes. That means evaporation refers to process by which water changes from liquid to vapor. That means from a pond, if you take, there is a pond, like this is a pond, for example. This is a pond or lake. So from here the water is escaped to atmosphere, and then condensation will happen, then precipitation will happen. That is a cyclic process. So water escapes to atmosphere not directly, so it will the liquid, this is liquid, right? This is in liquid stage. It will convert it into vapor. From vapor it will go to condensation and it will come back. Okay, this is what evaporation. So evaporation, when we are seeing the thing, evaporation is crucial component. So in hydrological cycle the major loss is evaporation only, evapotranspiration, this kind of things. So now the factors affecting, what are the factors affecting evaporation? For example, the first one is temperature. Temperature, if there is a high temperature increases the energy of water molecules, enabling them to overcome intermolecular forces and escapes into the atmosphere as a vapor. So this is one of the affecting factors, means temperature will be there, humidity will be there, wind speed will be there, and the surface area, whether the surface area is small, whether it is a pond or a lake or kind of things, and what is the air pressure at that particular location, and how the solar radiation, means sunlight provides the energy needed to heat, how it is making, and nature of the liquid, like different liquid having different evaporation rates depending on their physical properties. That is obviously true. For example, water evaporates more slowly than alcohol because its higher heat of evaporization and stronger hydrogen bonds. Next, salinity. This is very important. Salinity, I will tell. In a saline water such as sea water, evaporate rates are slightly lower than fresh water. So evaporation rates are slightly lower than fresh water. That means the evaporation is more in fresh water, so evaporation is less in saline water. This is because the dissolved salts in water increases its boiling point and decreases the number of water molecules available to escape into the water vapor. So these factors collectively determines how fast or slow evaporation occurs in any form environmental, influencing local weather patterns, agriculture and water management systems. So now measurements. What are the measurements of the evaporation? That means evaporimeter, empirical equation, analytical methods. In particular, analytical methods, there are three types: water budget equation, energy equation, mass curve. So this will be expressed in mm or centimeters. The depth, evaporation rate means mm per hour or centimeter per hour. So what are the things to reduce the evaporation? So now we know the evaporation is the major thing which is affecting the basin hydrology. So what are the things will reduce? That is reduction in the surface area of the water body, like mechanical covers, chemical films, and using surface floors by planting trees. Now coming to the transpiration. Transpiration is nothing but it is it's a kind of loss with respect to plants. That means it's a measured with respect to phytometer. And evapotranspiration is a combination of evaporation and uh, transpiration, and it is measured with respect to two things, lysimeter and field pots. So now another coming loss is, we have discussed about evaporation, transpiration, evapotranspiration. Another loss is infiltration. Whenever the rainfall is happening, the water will infiltrate into the soil and it will recharge into the ground. That is what here in a way here I have shown with a figure. What rainfall is happening, that is rainfall is happening, it is infiltrating. So less infiltration means non-porous soil rocks, more infiltration porous soil rocks, then this will be the water table. So that means groundwater recharge. So infiltration is the process by which water on the ground surface enters into the soil. So this is also kind of the loss. Infiltration rate means the speed at which water enters the soil. Now then we know the infiltration means it will go inside the soil up to the water table we are discussing. So how we have to measure the infiltration? There will be the kinds like single ring infiltrometer, double ring infiltrometer, and rainfall simulator. This is also like a rainfall runoff analysis, we can tell. And measurement of subsidence of free water in a large basin pond, hydrograph analysis. These are the things which we can measure infiltration. So infiltration indices means, infiltration indices represent infiltration at an average rate. That means we can find indices. These are the very two commonly and important is phi index, Devel index. These both are very important and very commonly used things. So thank you for watching.